An improper rational function is one where the highest power of the numerator is greater than that of the denominator. So for instance, x squared plus 3x plus 5 over x plus 2. The highest power in the numerator is 2, and the highest power in the denominator is 1. So this is an example of an improper rational function. And what we have to do is to simplify such a function. I'll make this example 1. So we want to divide x plus 2 into x squared plus 3x plus 5. So we set up the division like that. Then we ask ourselves, what do we multiply this x by to get this x squared? We multiply by x. So I'm going to put the x here. So this x times x gives me x squared. X times 2 gives me 2x. Subtract. So x squared take away x squared is 0. 3x take away 2x is 1x. 5 take away 0 is 5. Now, what we have here is still needs to be simplified, because the power of x here is 1 and the power of x here is 1. So we need to continue. So what do I multiply this x by to get this x here? I multiply by 1. So 1 times x is x. 1 times 2 is 2. Subtract 5 take away 2 is 3. What we can then say is that the original function x squared plus 3x plus 5 over x plus 2 can be simplified to give us x plus 1 plus 3 over x plus 2. Second example, this is still an improper rational function because the power here is 2 and the power here is 2. What we want is the power on the bottom line to be greater than the power on the top line. So we need to carry out a division. It's x squared minus x plus 4 divided into x squared plus 2x plus 3. What do I multiply this x squared by to get this x squared? I multiply by 1. I'll put the 1 in this position. That's where the constant term is. So 1 times x squared is x squared. 1 times minus x is minus x. And 1 times 4 is 4. So 1 times x squared is x squared. 1 times minus x is minus x. 1 times minus 4 is minus, beg your pardon, 1 times 4 is 4. So underline, subtract, top line take away the bottom line, x squared take away x squared is 0, 2x take away minus x is 3x, be careful, 3 take away 4 is minus 1. So what we have then, what we can do then is say that this can be written as 1 plus 3x minus 1 over x squared plus minus x plus 4. Last and final example. Now, if we look at the top line, you'll notice we don't have any x cubed term and we don't have any x squared term. So how do we deal with that? Well, x to the 4 What I could maybe do is just put in a 0x cubed, that's 0x squared, plus 2x plus 7, and then proceed as normal. So what do I multiply x squared by to get x to the power of 4? I multiply by x squared, so I'll put the x squared here. X squared times x squared is x to the power of 4. X squared times 3x is 3x cubed. X squared times 2 is 2x squared. Subtract x to the power of 4, take away x to the power of 4 is 0. 0 minus 3, that gives us minus 3x to the power of 3. 0 take away 2, plus 2x plus 7. What do I multiply this x squared by to get minus 3x cubed? I multiply by minus 3x. So minus 3x times x squared is minus 3x cubed. Minus 3x times 3x is minus 9x squared. And then minus 3x times 2 is minus 6x. Subtract minus 2 minus minus 9, that gives us 7x squared. 2x minus minus 6 is 8x. So we've got one last operation then. What do I multiply this x squared by to get 7x squared? I multiply by 7, put the 7 here. 7 times x squared. 7 times 3 is 21x. 7 times 2 is 14. Subtract 8, take away 21 is minus 13. And 7 take away 14 is minus 7. So what do we have then? We have, so this original function equals x squared minus 3x plus 7. Now, I have to be careful with this. Both of these terms are negative, so what could we do? I can either write that as plus or I can take out the negative. Let me use the second way, so that's minus then 13x plus 7. I'll not include a bracket, but you should realise that both of those terms are now negative. And that's over x squared plus 3x plus 2.